and a bunch of data, numbers were collected, hundreds or thousands of numbers. But if you make a histogram with those numbers, how many between here and here, how many between here and here, I think we're talking about the return of mutual funds. There are thousands of mutual funds, about 64 of them. The way you measure a mutual fund is how much percentage increase or decrease you get every year. And the same that among all of them, the average was 4.5%. And the way you deal with 5%, that was the average. Using the symbol, it's a Greek letter mu, which I learned surprisingly that in Greece they pronounce it me. Everybody, well, American mathematician. Anybody Greek? Anybody Greek? Is this, looks like a U, like this.
Yeah.
Pronounce mu or me?
In Greek, it's
But, so why don't we pronounce it mu in America? I don't know. I'm always surprised by that, but I don't know what should I say it the right way, which is me, which no other mathematician will know what I'm talking about. It's called mu. And the thing, so everybody, the average is 4.5, but the data is spread out. It's showing up on, there's a camera somewhere. Well, if anybody can hear me, if you can see the blackboard, something. Send me a chat. Whatever. And this stuff won't anyway. I'm making pictures of the bell-shaped curve in case you can't see it. Yeah, I'm missing too much. I'm just pointing out, a bell-shaped curve is simply a summary of a bunch of data that there are very few at the extremes, and as you get more and more closer to the typical data, there's more of them. It's common sense. And as you go further and further away from the middle, the likelihood of finding somebody at the extreme is smaller and smaller. So, because of the fact that essentially this is a kind of a bunch of pieces of a histogram, without reminding you what a histogram is, it's the way of summarizing data, you can figure out how many people are higher than this, or how many people are lower than that, or how many people are between these two, how many mutual funds are between these two levels, by essentially looking at the area. Area is proportional to the size of the histograms, and as I started saying, the sigma, which is a spread, in this particular example, is 6.3, which is a big number. Now, a couple of things about this particular example I should point out, so we should get confused. And percentage, that's just a unit. 6.3 pounds, 6.3 miles, 6.3 seconds. So in this case, the percentage itself is the unit, which means we can ignore it. But the reason why it gets confusing is because the answer itself is in terms of a percentage. What percentage of all the mutual funds are between here and here. So keep that in mind. It's potential confusion. Also, another point I should point out, this is based on 64 specific mutual funds. The mean was 4.5. Now, again, for those of you who had stat one, I might remember some of it. There are two kinds of means. There's the mean of a population, which is very often used when you're talking about a theoretical bell-shaped curve. But then there's the practical mean, or the X bar, X with a bar on top, or the mean of the sample. This sounds, in this particular case, we're talking about a sample. Not that it's going to change any of the answers, but just in terms of, and likewise, there's the standard deviation of the population is estimated by the standard deviation of the sample, which is the letter S. Standard deviation. Sometimes we abbreviate it as D, or just S. So I just want to point out again, so just remind you of some fun things that you had stat one. And but now we are asked, so this is 6.3. If this is 4.5 and this is 6.3, it represents an amount of spread, because again, if this was 0, they won't be on top of each other, but they're spread out. If this was 63, it means they don't even go all the way up to here. I mean, some mutual funds had 63% return, and of course you could have a negative number for a loss on the fund. So if this is 6.3, you take 4.5, which is here, and add 6.3. So what we're looking at right over here with my figures is one standard deviation above the mean. Right, that's 6.3 plus 4.5. That's 8, 10.8. So this is 10.8. And to maybe make this a little, this is 4.5. This is 10.8. If you go 6.3 in the other direction, away from that, how much is 6.3? I mean 4.5 minus 6.8. 3, 2, so it's minus 2.3. So if you go in the other direction, it's minus 2.3%, percent of the. Okay, I'm just setting up the example, doing it the old-fashioned way, and then we'll see how we do it the modern way with stack crunch. And then the question is, first of all, how many are lower than 14.4? Minus 14.4. Well, where is minus 14.3? Minus 2.3. You go another 6.3 to the left, you're going to get a minus 8. Take another 6 to the left, you're going to get a minus 14. So minus 14 is way up here. 1 or minus 10, minus 14. It's out here someplace. So, I mean, and theoretically, the curve goes on forever. So minus 14.4 is here. And how many of these mutual funds are less than minus 14.4? Again, if you take the time to make a picture, first of all, you understand it better. You can avoid careless mistakes, because you know what the answer is, sort of, you can guess the answer. So since we're looking at how many are lower than minus 14.4%, it's practically zero. The answer has to be like 0.000001. Very, very small. That's the common sense or intuitive way, and that's how I recommend people do it the old-fashioned way. For the stat crunch, the way I would show my students, and you'll see this in the videos if you watch the videos that you care to watch, you would take this number and convert it to what's called a Z diagram. And you can see that Z diagram is also a bell-shaped curve, but it has special values of 0 here and 1 here. And there's a formula to do that, and we expect D equals X minus the average divided by the sigma. You get a number. Then you would then take that number and plug it into a calculator that has Z values. You look it up on an online calculator. You can look it up. Tables usually the front and back of the book had a Z table. All that might take you 5 minutes. Make a picture, do the formula, look it up. Have to decide, should I subtract 100, add 50, add 100? I mean, you're taking options. And after all is said and done, you might make a careless mistake. Here's how you do it in stat crunch. First of all, I'm going to try to go through some of these things today, but get more help. Stat crunch. Okay, so this is stat crunch that I've been plugging always. You probably won't use this, even this, maybe graphs a little bit of chapter 3. But almost always you'll be going here. And you'll be going into, and this again, someone has to show you this. I mean, you can play with it, but where once you get the hang of it, or once you get it right for one particular example, then it becomes a breeze. Turns out in chapters 11, 12, 13, 14, you'll be using T-stats, some Z-stats, regression, chapter 15 or 16, chapter 20, 25, chapter 14, 15, I believe. I don't think. But right now we're going to go to calculators, because we really want to do a calculation about a Z-score. Again, if you knew that, you wouldn't necessarily go to calculators, but I'm telling you, you go to calculators. And there's all these different calculators, and the one we'll be using mainly, not the only one, but we mainly will be for chapter 7, the normal calculator. If you click on that, this is what opens up. Now, it turns out this little diagram will solve the problem for you if you plug in the proper numbers. First of all, we have to plug in the mean, which we said was 4.5. The standard deviation, in this case, was 6.3. In the book. We want how many were lower than minus 14.4. And then you hit compute. But before you hit compute, I want to point out that you have a couple of other options. Maybe we'll see that in some other example. Sometimes the book asks you how many are bigger than a certain point, right? So be aware of that. So you got to change the less than to a greater than. But in this case, it is less than. And sometimes the book gives you a problem, which is pretty hard to do when you have to do it by hand. They'll give you the answer. The answer, let's say, is 0.01%. They'll tell you to work backwards. Well, what was the average? Or what was the what is that cutoff point? In other words, if you're given the cutoff point, you can find a percentage, but if you're given the percentage, you can work backwards and find out the cutoff point. This doesn't give you it. If you just type in one number, it gives you the other one. It makes it easy here. And finally, because I'm not sure if we'll be seeing every option and every problem, there are two ways of solving this. There's two types of problems. How many are lower than a certain number or greater than a certain number? But the slightly more complicated problem is how many are between two numbers? How many like have a profit of 5% up to 7%? Let's say that was the problem. Then you went something from here to here. I remember, just curious, a lot of you might have used this calculator, in which case you may not be aware of the trick how to solve that problem. I'm just seeing my own little side here. Anybody remember the old-fashioned way, not using the calculator, finding something between two numbers? Anybody remember how they do that? Yes.
You did it by the 68, 95, 99.7 rule?
That is found actually in the book, in the homework, test, I don't think. And I criticize myself for actually asking. I can defend it a little bit, but that used to be the old day before people had all this technology. And if you didn't memorize the normal table and you didn't have it with you, and you wanted to get a rough idea, so you had to memorize a couple of key points, like how many is one standard deviation from here to here is 68%. From here to here is 95%. You go out further, it includes them. Once you had those numbers, you could figure out some of the other pieces between them. And there are homeworks about that, but that's not, but I'm not referring to that. I'm referring to another way that it's not so important. What I was hoping somebody might remember, and again, maybe nobody learned it that way because it's old-fashioned. First, you find the area from here to here. You find the area from here to here, and you subtract the big area minus the little area, gives you the piece in the middle. That's the old way of doing it. The new way to do it is you just go, I'm not going to show it to you because I don't want to screw this up, but you click on between, and then all of a sudden, instead of having one X value, it gives you two X values. You just plug them both in. But anyway, let's go. And we know the answer should be 0, 0, 0, 0. Might actually round it off to 0. I'm right? Wrong. Okay, 0.001349. So less than 1/10%. So it's small. And the fact that if it would have popped out and said 33%, you would say that can't be. I've got to make it, but in the picture, it got to be a very small percentage. Okay. So that's using. Anybody have any questions about how I just got that answer? Yeah, I spoke about it for 10 minutes, but it took 10 seconds to do. Okay. Getting back, I'm going to get out of here. So I mentioned there are other help ways, and then we can go through another one. Okay, let's do part B. How many are higher? 4.5 or more. 4.5 is right in the middle. And if you remember your business, again, where a little knowledge is useful. Bell-shaped curve, the whole thing from here to here is 100%. It's symmetric, meaning this piece and this piece are both the same. It's got to be 50%. So the answer to the question, part B, without plugging it into the calculator, has to be 50%. How many are between minus 8.1 and 17.1? Minus 18 is here. 17 is here. So what would you guess the answer to be, what you have based on what we've been saying? What do you think part C is going to be?
95%.
Well, those, you can do even better than that. I think, maybe I'm wrong, but my intuition tells me you got to be, sorry, I apologize. You might be right, actually. Oh, it says minus 8. I didn't say minus 8 is around to down here. So maybe you're right. Actually, it might be 95%. So you're right. But the point is, you go back to the calculator. Anybody want me to do that? And then just plug in the two numbers and find out the answer. Returns of less than minus 1.8. Minus 1.8 is around here. This is 2 points, so it'll be around 20%. I don't know if it's necessary to do it. Ooh. I'm sorry, again, I talked so fast. Oh my God. Okay. Hold on. I am confused. I criticize students sometimes for not reading. I'm sorry, that's why you said about the 95. I didn't read this last part of the problem, which is they don't want you to do it this way. What I was giving you by the StatCrunch method did give you the exact answer which again is obviously better than an estimate, but they don't want you to do it that way. They want you to do it by what's called the one standard, the 68, 95, 99.7 rule, which again you can read up on. But I would suspect the answers come out the same. See. You know what? Maybe this is a good time to go to the other types of help. So we went through, we look it up in the textbook, that crunch, tech help, I'm not sure what that is. Maybe there's a problem, there's some kind of bug in the problem. Ask my instructor is very valuable to be aware of, and I welcome these questions. You do that, click on, anytime you're doing a particular problem, and you click on Ask My Instructor, it sends me, it's my email, the question, and more importantly, because everybody has different numbers, it sends me the actual numbers, and hopefully it'll write me a little message saying, Professor, I can't do part B. Maybe you can do other parts of it. What am I doing wrong? And very often I'll just tell you, like, oh, you forgot to take a square root, or you forgot to divide by n-1 instead of n. So I can tell from the numbers that you're showing me. Anyway, it's a very valuable thing to have that opportunity and solve that problem. Maybe I should send it to my professor because I'm still not getting it right. Okay, now, the two main ways of getting help is help me solve it, where the book walks you through the problem really step by step in a very, like a tutor. And then there's two versions of this. One is they solve this particular problem where they expect you to solve it, they do plug in numbers step by step. And the other one is they'll just walk you through everything step by step without you having to do too much. So let's try one each. We solve it. 24 parts remaining. What does that mean? It's repeating the problem for you. They're reminding you of the relevant rule, which means again, you don't have to read the book, you just get it right here. It means that a normal to model, one standard deviation contains 68%, meaning if you go, picture came out more here, if you go out one standard deviation, here to here, it contains 68%, which is about, 67 is 2/3, about 2/3 of the data, which is the bulk of it. These are people's heights. So most people are within, the mean or plus or minus one standard deviation. If you go out two standard deviations, 95%. So if we go back to the book's example of minus 14, how many are lower than minus 14.4? Yes, the calculation that's relevant here is, I guess you do have to go back to this formula. You take the number, which is minus 14.4, minus the average of 4.5 divided by the signal 6.3. Did anybody by no chance do that? Probably comes out to -3, I imagine, because that's got to be the -1, -2, or -3. Let's do that. 5 minus minus by 6.3. Oh, okay. It's like people who have big math mistake. 4.5 versus 14.4. You add them, so it's 4.5 minus 14.4. So 4 equals 18.9 divided by 6.3, and it comes out to -3. So it's -3 away. So if the rule says that from -3 to +3 means 89.7% of the data, how much is outside limits. Whole thing's 100%, so we're missing 0.3%. And so 0.3%. Like point, and then, but that's the two of them together. So we only want how many lower than minus 14.4 is going to be half of that. So it comes down to point, I don't know, 0015, is that the number? What did we say the answer was? 0014 was, because those are the slight approximation. And interestingly, if I would have put that answer in, that would have bookmarked me when I said minus 4, what do they say, 00139 or something. The bookmarked me right because the way I set up the, again, there's many ways you can set this stuff up. If somebody is off by, I think even a little bit, the still marks are right. So in this case, I really made a mistake, but it was marked right anyway because it was very close. But they really did want you to do by the, okay, so they remind you of the rule. Let's see if we make a picture. They made a picture for you, okay? And it's telling you what the rule is about between blah, 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 and now. I think that's, I don't think part C, I'm not reading it carefully, but looks like it's right. Okay, continue. Then they figure out that they do that formula, the Z number. And I think they got their number minus 3. See this? Oh, it's where it's supposed absolute value, so it's going to be a plus 3. What's next? Since it's part B, that's the relevant one, about 3, check hands. I mean, the point, I'm just giving you an example. It's not the best example to show you how wonderful their help is, but this does show you how they can take you through one by one. Remember that was at point 3 that we said there. So it's point 3 is the answer here. Carefully. And finally, it tells you that you're supposed to split it evenly. What I'm telling you again, it's like having a tutor do this with you, and so it's 0.23. What do we say? 0.3, 0.15%. Okay. Now so we're done with that part of it, and now they probably move on to another one. Okay, that's really not that useful. That was help me solve it. View an example is similar, and that again, they give you the same problem. It's a different problem, actually, different numbers, and they put a very similar problem. They tell you it. They tell you some stuff about the 66, the 68, 95 rule. Then they warn you about the rule, and then they here they're solving. They're not asking you to start actively put numbers in. You're just like getting a tutor showing you how to solve the problem step by step by step. Well, like I pointed out to you, and again, I apologize for picking this particular example. In real life, you wouldn't go through all this. You would go basically do it by that Z calculator.